Hello everyone. In this video I am going to show you how to fill in a unit circle from either the first quadrant or in fact from scratch. So the question I've got written up here says the unit circle has 16 special angles that are commonly used. The first 5 are labeled below in radians and degrees, so that's the first quadrant here. And then, oh sorry, my mouse was on the wrong monitor. That's the first quadrant here. And the coordinates of the corresponding points on the unit circle are also labeled, and we want to fill in the same information for the other 11 angles. Okay, so I am actually going to do this on my paper here, and I'll show you how to do it as well. Oop, oop. Let me just align my screens here. Okay, so forget about this unit circle over here, but you can look at the first quadrant there if you want. I'll show you how I remember this information. So for the unit circle, let's try drawing one first of all. All right, not entirely circly, but good enough. So this is the y-axis and the x-axis, and I'm going to split each quadrant in half like this. And then I'm also going to split each quadrant into thirds. This. Helps if I turn it a little bit. Okay, not perfect, but good enough to be getting on with. All right, so for labeling the angles, first of all, your 0 angle is right here, and that's 0 in radians or 0 in degrees. And then 90 degrees is a right angle, right? Everybody should know that. So 90 degrees is this y-axis angle here. And then for radians, the way to remember it is that pi is a half circle, because the circumference of a circle, oh, I was going to put these inside. The circumference of a circle is 2 pi, so halfway around is pi. All right, and then you also know that a straight line angle is 180 degrees, or 2 right angles. Okay, so from just this much information, you can pretty much work out all of the other angles. All right, so since I'm going to do it in radians first, I think. Since pi is a half circle, then a quarter circle, which is where 90 degrees is, should be half of that. So that's going to be half of pi. So that is pi over 2. All right, and then what I'm going to do is I'm going to count around the circle and fill in all of the half pi angles. So from here to here is half of a pi. So another half of a pi would be here. So I'm going to go 0 pi halves, 1 pi halves. This is 2 pi halves, which is the same as pi. So then down here is 3 pi halves. So this is 3 pi halves down here. Okay, and then if I kept going, this would be 4 pi halves. That's the same as 2 pi, which is the same as 0. On a circle anyway. All right, now let's do the pi fourths angles. So if 90 degrees is pi halves, the upright one, then half of pi halves should be pi fourths, right? So the 45 degree angle here is going to be pi fourths. And now I'm going to do the same thing where I count around the circle. So this is 0 pi fourths, 1 pi fourth. This is 2 pi fourths upright, which is the same as pi halves. 3 pi fourths is this one. So this is 3 pi fourths. 4 pi fourths is right here. That's the same as pi. 5 pi fourths is this one. So 5 pi over 4. And then continuing on like that, 6 pi fourths is down here. That's the same as 3 pi halves. And then 7 pi fourths is over here. So you're counting your way around by fourths. 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths. Just counting. Okay, now let's do the thirds. So when you have pi and you cut it into 2 or 3 thirds, the first third is here, this angle, and then the second is from here to here, and then the third is from here to here. This one's a little harder to see than the fourths, but this is pi thirds right here. And now I'm going to do the same counting around by thirds thing. So this is 1 pi third, this is 2 pi thirds, and since we haven't labeled it yet, I'll go ahead and label it. All right, and then 3 pi thirds would be here, but that's the same as pi. So this will be, let's see, where's the next one? This is going to be the next one. My sort of unproportional drawing makes it look too small, but this would be 4 pi thirds. All right, and then 5 pi thirds is down here. Wait a minute, I've done something wrong here. Yeah, I did this wrong, sorry. Okay, I knew something was afoot because this looked too small to be 4 pi thirds. Right, okay, so 1 pi third was here, 2 pi thirds was here, 3 pi thirds was here. Oh, right, okay, you have to go all the way to here to get 4 pi thirds. Yeesh. 4 pi thirds is here, and then the next pi thirds is over here, so this is 5 pi thirds. Thankfully, if you get this like printed as a test question, it'll be more proportional. All right, and then that means 6 pi thirds is all the way back up here at 0, because 6 thirds is 2, right? Okay, so if you've done this correctly, then when you come all the way around to 0 again, you should have 2 pi. Okay, and now lastly, let's do the 6th. So when we have pi thirds here, half of a third is a 6th, right? So this is pi 6. And then we're going to go around the same way, and there's 3 in every quadrant, so that can help you count. So 1 pi 6, 2 pi 6, the same as pi thirds. 3 pi 6, that's the same as 1/2. 4 pi 6, 5 pi 6. Okay, and 5/6 is a little less than 1, and this is 1 pi, so okay, we're still on good track. So this was 5/6. 6/6, 7/6, 8/6, but we already have 4 thirds there. 9/6, which is the same as 3/2. 10/6, same as 5 thirds. And finally 11/6. Phew. Okay, and then if we went one more, we would have 12/6, which would be 2 pi. All right, so we did all the radians, angles, and now for the degree ones, they're actually a lot easier. In fact, you could do the degree ones first and then I guess just convert them to radians if you wanted to, but I think the better way to learn to think about it is to actually understand these fractions. So these angles here are 30, 45, and 60, and then the distance between, like in each quadrant, this bigger 2 angles here and here are 30 degrees each, and then these smaller ones here and here, those are 15 degrees each. So you can kind of just start adding on 30s or 15s as you go around. So 90 plus 30 is 120, 120 plus 15 is 135, 135 plus 15 is, let's see, 140, 150, 150 plus 30 is 180, so we're still doing this right. 180 plus 30 is 210. 210 plus, now we're doing a smaller angle. 210 plus 15 is 225. 225 plus 15 is, let's see, 230, 240. 240 plus 30 is 270, and I already knew this was supposed to be 270, so that's good. 270 plus 30 is 300. 300 plus 15 is 315. 315 plus 15 is 330. And then 330 plus 30 is 360, which is back where I started. Okay, so I've done all the angles. And now let me show you how to remember the sines and the cosines. You might be given the first quadrant, but if not, you can remember them like this. So they follow a pattern. Firstly, you can do these points yourself because it's the unit circle. So this is a radius of 1. We're still in the xy plane here. So this coordinate here is, we've gone over 1 from the origin. So this is 1, and then your y value is 0 because you're on the x-axis. And then same way up here, this is 0, 1, because we've gone up 1 on the y-axis. Then for these other ones, they follow a pattern. So counting down, it goes this is the same as square root of 4 over 2. This is square root of 3 over 2, square root of 2 over 2, and then square root of 1 over 2. And then this is also square root of 0 over 2. But you can simplify square root of 1 is just 1, right? And then this is also like this one here. You can make that follow the pattern too, because it's square root of 4 over 2. That's 2 over 2, which is 1. And then this one also follows the pattern because this is square root of 0 over 2. So you can kind of force the pattern in there, but even if you don't, like, it's still counting down from the larger x value to the smaller one up here. And then going in the other direction, they go backwards, so it's square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and then square root of 1 is just 1. Okay, and then these are your x and y values at the points on the unit circle that are touched by these angles. Okay, and remember, this is to help you find these. This relates to right triangles because we can drop a little line down from each of these and find a right triangle. And so this is the cosine of the angle here. This is the sine of the angle here with the positive x-axis. All right, now when we go around to these other quadrants, we can no longer fit the angles into a right triangle. So we extend the definition of these trig functions, sine, cosine, and tangent, to just be that cosine is the x value of the point on the unit circle, and sine is the y value of the point on the unit circle. Okay, because these angles over here, like to there, are too big to fit in a right triangle, so we cannot use the right triangle definition anymore. Okay, but for filling in these coordinates, it's just you're using symmetry from the first quadrant. So in the other quadrants, quadrant 2, x is negative, y is positive. So you're just going to take these values over here and just flip them over here, make the x values negative. Sorry, I just smacked my camera. In the third quadrant, x and y are both negative, so you're going to flip them down here, like along these lines, and just make both coordinates negative. And then over here, x is positive and y is negative, so you're just flipping these ones down. Okay? So let's just go ahead and we can do it. So I'm going to copy this one over to here. You can see they have the same y value, and the x value is just being flipped to negative. So this is going to be negative 1/2 square root of 3 over 2. This one is negative square root of 2 over 2, square root of 2 over 2. And if you teach trigonometry for as many years as I have, then these just live in your brain, you know? And you hardly even have to look anything up. Okay, and then flipping down, let's see, so here I'm going to keep the x values, but I'm going to switch the y values to negative. It's not even that I actually teach trigonometry, you know, it's that I use trigonometry in my own research. So, but I do have to kind of reteach it whenever my students need it because they always forget about it. Trigonometry is so cool, you guys, so seriously. All the things that you can do with it, like you can measure the radius of the Earth, you can measure the distance between the Earth and the Sun, you can measure all kinds of things. It's so cool. Okay, negative square root of 2, negative 1/2. Okay, so I think I've got, does that make it really clear that that's a negative there? Okay, so I think I've got all of them filled in there, and you guys need to practice doing this as well. See you in another video.